right, second semester review. Right triangles and trig. So FGH, F is a right angle. FH is 9 feet. FG and GH, find FG and GH using 45, 45, 90. Alright? Well, remember, when you have a 45, 45, 90, the legs are the same. So GF, FG, is 9. And then, when you're going back and forth between the hypotenuse and the one of the legs, our magic number is going to be radical 2. Because it's an isosceles triangle. Isosceles has two sides the same, so that reminds us of radical 2. Now, when we're going from the leg to the hypotenuse, the longest side, we're going to multiply by radical 2. If we were going from the hypotenuse to the leg, we would divide and then have to rationalize. In this case, we're going to the hypotenuse, which means simply it's 9 radical 2. GHI. GI is 8 feet, hypotenuse. I is 45, which makes this 45. To find the legs, we're going to do 8 divided by radical 2, which means we need to rationalize. So that's 8 radical 2 over 2. Cancel. So HI and GH are both 4 radical 2. ABC. Horrible triangle. B is 30. That makes this 60. BC is 12 feet. Okay. Well, the easiest one to find is always the short side. And it helps to label these short and long. The short side is always half of the hypotenuse. So AC is 6. Remember, when you go from the short to the hypotenuse, you multiply by 2. If you're going to the short side, you divide. Now, since 30, 60, 90 is scalene, 3 different sides, our magic number is radical 3. So AB is simply the short side times radical 3. ABC again. This is my 30. That's my 60. AB is 12. Well, that's my long side. So I need to do 12 divided by radical 3, which I need to rationalize. So that's 12 radical 3 over 3. Cancels 4. So that makes this 4 radical 3. And then if I'm going to the hypotenuse, I just double the constant, 8 radical 3. Solve for x. Well, we have to work our way over. This is the long side. This is the hypotenuse. So before I get the hypotenuse, I need the short side. So the short side is going to be 60 divided by radical 3. I'm sorry, 13. Which means I need to rationalize. So that's 13 radical 3 over 3. And that does not reduce. So that's over here. Now, to find the hypotenuse, I double that. So that's 26 radical 3 over 3. I know that's kind of a nasty one. It is. If this is 45, that's 45. 45. 45 which makes this the same thing. And going from the leg to the hypotenuse, we need to multiply by radical 2. And remember, you can only multiply radicals times radicals. So radical 3 times radical 2 is radical 6. So x is 26 radical 6 over 3. Nasty, but that's it. All right, 45, 45 minus 90, that makes that 9. And we multiply by radical 2. That's 9 radical 2. That's my short side. To go to my long side, I'm going to multiply. I don't need to go to my long side, actually. I just need to go right to my hypotenuse. From the short side, which is easy, I just double the 9, 18 radical 2. Solve for x. This is our good old friend Pythagorean theorem. X squared plus 5 radical 2 squared equals 10 squared. X squared plus 5 squared is 25. Radical 2 times radical 2 is just 2 equals 100. So 25 times 2 is 50. I'm going to subtract that and get x squared equals 50. Square root both sides. X is the square root of 50, which breaks down to 25 and 2. We want to look for those perfect squares. And remember, if you don't have them memorized, real quickly when you get your test, you can just take your calculator and do 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, and keep going. And have a reference right there. So this works out to be x equals 5 radical 2. If the question asks for a decimal or decimal measurement for a real world problem, you would just take your calculator and do 5 times radical 2 and get your answer. Okay, 8 squared plus x squared equals 10 squared. Remember, always identify where your hypotenuse is, because that is C. The other ones are interchangeable. So that's 64 plus x squared equals 100. Subtract 64, and you get 36. Square root both sides. X equals 6. Okay, sine. Let's just write it up here. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So, ka, toa. So sine of x. Here's Grover. Sine in, and we always want to identify our hypotenuse. It's opposite the 90 degree. So here's Grover. He wants OH. So over there, over the hypotenuse of 30. Cosine of x. Here's Grover. 18 is right here. Not over there, right here. 18 over the hypotenuse of 30. And the tangent is OA, all the way over there, over the adjacent. Okay, Z. Here's Grover. Sine. Remember, this is our hypotenuse. It's flipped over, but it's opposite the right angle. So, all the way over there, over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the over there, opposite, over the adjacent, right here. Okay, round your answer's nearest 100. Solve for x. So, that's our hypotenuse. This is our adjacent. So that's ka. So the cosine of 65 equals adjacent over x. Hypotenuse. Remember, in this case, these two switch sides. X equals 18 divided by cosine of 65. And you literally just take your calculator and do 18 divided by cosine 65. Something didn't work out. Okay, figure out my error. What was my error? The calculator was on the wrong setting. So 18 divided by the cosine of 65 is 42.59. Alright. Okay, Grover's here. Here's the hypotenuse. Over there. So that's the sine. So sine of 48 equals x over 20. All you do is literally type in 20 times sine of 48. 20 times sine 48. 14.86. Opposite, adjacent. That's tangent. Tangent of 65 equals x over 12. Just like the last one, you type in 12 times tangent of 65. 65. And you get 25.73. Over there, hypotenuse, that's sine. So sine of 57 equals 18 over x. Again, these two switch places. X equals 18 divided by sine of 57. You just type in your calculator, and you get 21.46. Okay, I apologize. Had a little technical difficulty and just went through a bunch of problems and realized for some reason it wasn't recording. So these are already filled out. I'm just going to walk through them real quickly. Number 15, you have, you're trying to find the angle. So the opposite side is 16, the adjacent is 19. That's tangent. Remember, whenever you're trying to find an angle, you can't remember where we were on this. So you do second tangent, right? And then you just type in 16 divided by 19. There it is right there. And there's your answer. 40.10. Okay, number 16. From where Grover is, you have opposite and hypotenuse. So that's sine. You're going to do inverse or second sine. Type in 6 divided by 15. And get 23.58. Now, 17 was a two-step process. We used the 46 and the 20 to find the height of the triangle there. That new x. I should have made a different letter. So, we're trying to find the opposite side, and we're given the adjacent side of 20. So that's tangent of 46, x over 20. Remember, all you're going to do is type in 20 times tangent of 46, and you get 20.71. That's the height. Now we're going to use that height to find the opposite side. Well, we're not using the hypotenuse at all, so that's tangent again. Except we're using 31. Opposite over adjacent, x over 20.71, is 12.44. Number 18 is similar. We're going to use 36 and 20 to find the height, and then use that height to find the hypotenuse. So we say cosine of 36 equals adjacent, unknown, over hypotenuse, 20. Multiply 20 times cosine of 36 in the calculator and get 16.18. That's our height. Now we're going to use the adjacent side to 30 degrees to find the hypotenuse. That's cosine again. So cosine of 30 equals adjacent, 16.18 over x. Remember, you switch the x to the cosine of 30, and just type that in, you get 18.68. Number 19, 12-foot ladder leaning against the side of a building, 3 feet from the wall. That's adjacent hypotenuse. Cosine of x, you do the inverse cosine again. 3 divided by 12, you get 75.52 degrees. Don't forget, whenever you're trying to find the angle, the answer is going to be in degrees, and you're going to use inverse. Hit pause if you need to anywhere along here. Same problem, just different numbers. 8 foot long, 4 feet out. So you're going to do cosine of x, 4 over 8, which is 60 degrees. Now you need to find how high it is on the wall. There's 2 ways to do this. Knowing it's a 30, 60, 90, you just take the short side 4 times root 3. That's about 6.93. Or you can use 4 squared plus b squared to get equal 8 squared. And take the square root of 48, which is 6.93 feet also. Either way works. And it only works as a 30, 60, 90 triangle. If it was 59 degrees, you'd have to use the Pythagorean theorem. But you can take the shortcut of just multiplying by radical 3. Okay, here's where I left off. John wants to measure the height of a tree. He's 100 feet out from the base of the tree and looks up at a 33-degree angle. That's opposite over adjacent, tangent, x over 100. You multiply 100 times tangent of 33 and you get 64.94 feet. Now, it wants to know what is the minimum length the ladder he will need. Well, remember, the length of the ladder is here, right? So, that's going to be, you can use any number you want. You can use the 100, or you can use the 64.94, but that's an approximation. So I would suggest using the 100, which is adjacent, and you're trying to find the hypotenuse. So that's cosine of 33 equals adjacent over hypotenuse. Again, these two switch. So y equals 100 divided by cosine of 33. You type that in your calculator, and you get 119.24 foot ladder. So 120 foot would do it. Solve for x. Well, here we're going to use the law of sines. These two are opposite each other, 46 and 18. Now, we're trying to find this, but we don't have a. But we can find it. 46 plus 17 is 63. If we do 180 minus 63, we get 117. So sine of A over A is equal to sine of C over C. All we do with this one is literally type this in. Sine of 117, make sure you pay attention to your parentheses, times 18 divided by sine of 46. And you get 22.295. 5 rounds to 9 to 0, which rounds the 2 up, so it's 22.3. Okay, again, we have these two and those two. So sine of x, as soon as you see that, you should be thinking inverse, over 38 equals sine of 36 over 34. So, calculator, we're going to do 38 times the sine of 36 divided by 34. That gives us a decimal. Now we're going to do inverse sine of that decimal. And put in, the more numbers you put in, the better. 69364584. More accurate it's going to be. That's going to be 41.07 degrees. last page for this unit. We're going to use the law of cosines here. And it's just the formula off the sheet. X squared equals the one side squared plus the other side squared minus 2 times the one side times the other side cosine of 89. Now, for this one you got to be careful with your order of operations. So 12 squared is 144 plus 16 squared is 400. So x squared equals 400 minus 2 times 12 times 16. That's 24 times 16. 384. Times the cosine of 89. Now, you cannot do 400 minus 34. Because the 384 is attached to the cosine of 89. You actually have to move okay, sorry, you don't have to move anything over. I was thinking of a different problem. So you're going to do 400 minus 384 times the cosine of 89. And that gives you 393.29. So that's x squared. I think that's what it was. So now we need to square root both sides. So we use second square root, 393.29. And the more accurate you can do, the better. 82759. 19.83. All right. So, similar problem. 30 squared. This time we don't know the angle. Equals 26 squared plus 28 squared minus 2 times 26 times 28 times the cosine of x. So, this is going to be 900 equals 1460 minus 1456 cosine of x. This is the one I was thinking about. Let's get ahead of myself. Now this one you have to be careful with because this is 1456, negative 1456, is the coefficient is being multiplied by that. So we have to subtract 1460. And do 900 minus 1460. I have trouble with that. That's negative 560. Negative 1456 cosine of x. Now we're going to divide by the coefficient. Divide by negative 1456 and get that decimal. And that's the decimal we're going to do inverse cosine. 0.384, again, the more decimals the better. 6153.846. This is going to give us a more accurate answer. And there's our answer. 67.38 degrees. But you got to think about this one, especially at this point. This is like saying, 20 equals 4 minus 2x. You can't say 4 minus 2 and do 2x and then divide by 2. That's wrong. You got to move this over first, then divide by the negative 2. Just keep that straight. Okay, 26. Solve for all the missing sides. So draw a picture. Doesn't matter where your ABC is, you choose. I'm going to put A here, A there, B there, C, C. So A is 31 degrees. This is 67 degrees, and this is 82 degrees. Now where did I get the 31? Well, I did 67 plus 82, and subtracted from 180, leaving 31. Now, I need to find, I know A is 7 right here. So I'm just going to do two law of sines. I'm going to say sine of 31 over 7. That's my starting point for both problems, because that's my reference ratio. Now, I'm just going to do B, which is sine of 67 over B. And then I'm going to do C, sine of 82, that's 2, over C. And all I'm going to do is do 7 times sine of 67 divided by sine of 31 on my calculator. So B is 12.51. I'm having trouble with 2's tonight. And then 7 times sine of 82 in the calculator divided by sine of 31. C is 13.46. Almost there. Remember we said that these are not to go with these problems. So you're just going to draw your own. A, B, C. C is 40. A is 3. B is 4. Area formula. Area is 1/2. 3 times 4 times the sine of 40. And you just type that in your calculator. 4 times 3 is 12. Half of that is 6. So it's just 6 times sine of 40. Area is 3.9 units squared. Simple idea here. See what we got. A, B, C. A is 4, B is 3, this is 41 degrees. Well, I can use law of sines, these two and these two. So sine of 41 over 3 is equal to sine of A over 4. So I'm going to do, on my calculator, 4 times sine of 41 divided by 3. So sine of 41 times 4 divided by 3. That's going to give me a decimal. And then I'm just going to do inverse sine of that decimal. 0.874745 61.01 degrees. So about 61 degrees. So A is 61 degrees. Well, I don't have to do law of sines again, because now I just have to add 61 and 41 and find out that C is 78 degrees. And then the area, we've already done this, the other one, 1/2, 4 times 3 times the sine of 78, and the area is about 5.9 square units. And that's it, finally, for this chapter.